Oh, hello, friends. So, picking up where we left off, let's start talking about expressions. So, we just talked about data types. And we talked about how data types are two things. Who can tell me what they are?
Primitive?
So that's one of our like kinds of data types. So we had primitive and reference objects, or primitive and reference types. So objects are reference types. Everything else is primitive. Um, but think like definition of a data type.
You said like values that are
Yep.
allowed and
Yes.
what you can do or what you're allowed to do with the values.
Bingo. There we go. So range of legal values and what you're allowed to do with those. So values are things like the string one or the number one or true or an object or an array or a function or a promise or a DOM node. All of those are values. One, one, true, an array, an object. All of these are values. An expression. Anybody remember the definition of an expression?
Evaluates to a value.
Evaluates to a value. Oh, you had that locked and loaded too. Oh, it's making my heart sore. Something that evaluates to a value. So that's an expression because it evaluates to one. That's an expression because it evaluates to two. Two's a value. Not false is true. A template literal that evaluates to a string, so it's an expression. Calling a function is an expression. Evaluates to its return value. A spread operation. That's an expression. It'll evaluate to some new object. All of those are examples of expressions. Ask me some questions about them.
Why does the spreading of an old object evaluate to a value? Because it's
Because
creating a new
great question.
object?
Because this will result in a new object, and this isn't a value, but it'll turn into one. So that makes it an expression.
Okay. Is a variable or a constant after we've defined it able to be considered an expression as well?
Like if I did something like so if I do that, that's an expression. A was.
Mhm.
If I do A plus 3 plus 4, put the whole thing in parentheses, uh, raise it to the second power, All that's an expression.
How can one be an expression and a value at the same time?
Because values are expressions, because they evaluate to themselves. So like if I put 24 in here, 24 evaluates to the number 24. That makes it an expression, because the definition of an expression is something that evaluates to a value. Well, a value evaluates to a value.
So a string could be a value as well.
Totally. That is a string that evaluates to the string fart. If I was concatenating, that's an expression that evaluates to this value.
Makes sense.
So with that logic, like you have the dot length, and that would be dot map, dot find, dot filter, all of those would also be expressions.
All of them.
Wow.
Yeah, light bulb's going off. If I do that and I map over it, that's an expression that evaluates to this array.
Now the array isn't an expression. It's an object.
The array is a value, which means it's an expression because values are expressions that evaluate to themselves. But this isn't a value. This is a value. This is what the expression evaluated to, and also values are, or expressions. Or sorry, God, I'm getting myself mixed up. Values are expressions because they evaluate to themselves. That's like an academic distinction, by the way. I don't know that every programmer knows that. Even I don't know that it's like important to know it, but since the definition of an expression is something that evaluates to a value, a value, like you can see it, it just evaluates to one of these days. My computer has a hard time running Zoom and OBS and Discord at the same time. Whenever that gets around to it, it'll poop out a 5. There we go. Because that's what it evaluated to.
So all values are expressions, and expressions are something that evaluates to something.
Yes!
Okay.
Perfect, Brad.
Yes! Love it. More questions about expressions.
Brad, can you say that again? I want to write that down.
All values are expressions, and an expression is something that evaluates to something.
Yep. Specifically evaluates to a value.
To a value. Okay, cool.
Would you be able to show us something that might look like an expression but isn't?
Ooh. Yes.
Sweet.
I like that idea too.
That is not an expression. Anybody tell me what it is?
It's just a variable. It's been defined, but it hasn't been evaluated.
Yes. Like that's an
Sign.
expression, just the 2 is. But the whole thing is
Right.
a
Statement?
statement. Because we're taking an expression and saving it in a value. Variable assignments are statements, not an expression. 2 is an expression. The whole thing is a statement. A function declaration. Not an expression. Actually, not a statement either. It's a declaration.
But calling the function is an expression.
That's an expression and a statement. Because, yeah, that's going to evaluate to undefined because it doesn't return anything. So it is an expression that evaluates to the value undefined. Because remember, undefined and null are the only legal type of null, or the only legal value of null is null. The only legal value of undefined is undefined. But they are values. So those evaluate to undefined because it didn't return anything.
You said it was also a statement. Why?
Because it is a standalone instruction to the computer. If I just write a string or a number or like an expression like this, the computer doesn't do anything.
It's when you call it.
Bingo. That's saying, hey, execute this function. Hey, save this variable. Calling a function.
So
Go ahead.
So it's the instruction is what makes it a statement. The fact that it's going to give you a new value is what makes it an expression.
Yes.
Okay.
And really, like, we got a pretty short list of things that count as statements. Assigning something to a variable, calling a function. What other things are statements? Reassigning, mutation. Those are statements. So if I do const a, const some number, actually let some number equal 0. That whole thing is a statement. 0 is a value and an expression. Oops, already had it. So I have some number, and then if I reassign it, that's a statement. If I do some number plus plus to increment it, that's a statement too. Statement. Because I'm like changing the value. I'm telling the computer to like execute something basically. Which is a little bit different than telling it to evaluate something. I don't want to get a value. I want to change something about the state of the program. Statements.
All right, I'm a little confused. You lost me there because when you did the plus plus, you did change the value because it created a different number.
It didn't create a different one. It changed this existing one. So that's a mutation. That's a statement.
Okay.
So if I look at the value of some number now, it's changed. Because this is like things like plus plus, it's effectively like calling a function. And in fact, plus plus is just a shorthand for some number equals some number plus 1. That and that are the exact same thing. And this is a statement.
and that's not an expression.
Some number plus 1 is an expression. The whole thing is a statement.
Okay.
Because this evaluates to 5. The statement is take this expression, evaluate it, so it's 5, and assign it to be some number. The assign is what makes it a statement.
Okay.
How about a fetch request? Is that going to be falling under the category of a statement at that point?
Oh, great question. So, yeah, if I do a big old fetch chain where I do let's take a look at this. This whole thing is a statement because it's a function call. That alone, like, qualifies it. The whole thing is not an expression because all of this, well, yeah, it does. This is an expression because this whole thing will evaluate to a promise. Like, I can even save it in a variable. I could say something like, the fetch so far. So I could save it in a variable like that. That makes all of this an expression.
Because it evaluates to the value of your promise that you've received back.
Ding, 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 ding. Because I can keep chaining off of that. I can do the fetch so far. We can see that it is currently this promise. I can keep thenning and catching and whatever else. So that makes this whole thing an expression that evaluates to a promise. And the entire thing is a statement. And even if I wasn't assigning it, the whole thing would be a statement because I'm telling it, execute this fetch function. And then call this function when it comes back, and then call this function when it gets back. Response is a value, which makes it an expression. This is also a statement because we're executing a function there.
Would by adding the const to the fetch so far and then setting it equal to our full statement and expression there, would that then be a declaration, or is the const the fetch so far because we're declaring it equal to the whole statement there?
No, like, good instinct, but really the only declarations that we'll do in this program are functions. And not every way that you define a function is a declaration. It's literally just the one that starts with the word function. That is called a function declaration. This is called, wait for it, a function expression. Because we're treating it as an expression there. That's a declaration. The only two declarations that we're going to do in the program are function and class. And we're still a ways off from class. Those two are declarations. There are other things in JavaScript that are declarations. Don't worry about them. More questions about expressions and statements? take a look at this programming concepts in JavaScript. Because this overviews basically everything that we've talked about so far today. Data types, values, operators, I guess we haven't talked about. These are part of the things that we can do to a value. That makes it part of a data type. So we can do all these math ones. Those are legal operations with numbers. Can't do them with strings. Can't do them with Booleans. You can do them with numbers. Comparison. We cannot... No, we can compare just about everything. We can't use all of these comparison operators. Like you can't say this string is greater than this string. That operator doesn't make any sense in that context. You can say this string is equal to this string, or that this string is not equal to this string. You could say the string's length is greater than the length of a different string. But, and this is why, like, I've belabored the point so much on expressions, is that if I have that string and I do dot length, it's not a string anymore. This expression evaluates to the number 4. This expression evaluates to the number 1. And so then this whole thing simplifies down to 4 is greater than 1, which is true. And when we have these big long chains, figuring out what an expression evaluates to is critical in understanding your code. Calling fetch evaluates to a promise. Promises have .then methods on them, so that's why we can call .then there. And then everything else that gets returned from these are also promises, so we can continue to .then off of them. This response.json method evaluates to the parsed body of the HTTP response. That's what that ends up being in the next thing. So like, this is why understanding expressions is like super important, because everything we do is like expressions on expressions on expressions, and figuring out what something evaluates to is really critical in figuring out how you can use it. Because I can't do meaningfully ASDF is greater than A. Like that evaluates to a value, God knows why. I don't know what it's comparing on that. Maybe it's doing the length, maybe not.
Was like, could it automatically be doing the length?
Could be. But like, it could also just be like, I don't know, I got to give you something. And so there's a lot of things in JavaScript that are like that, where you like can accidentally get a value. And sometimes like the order that you do them in matters, like JS truth table weirdness. So, all right, so this should be symmetrical, and it's not. Here. Some of these are not the same. Or no, I guess it would be comparing this to this, that to that, this to this. Shoot. There is, yeah, there's some stuff in here where like the order is important, and that's weird. Like having something on the first side of the double equals or the second side of the double equals is a problem, because it tries to coerce the number coerce whatever you're comparing. Versus if you use triple equals, the only thing that it will do is compare the value and the type straight across. So like in this one, there you can kind of see it in the hover over. The string 0 is equivalent to an array with the number 0 in it. All kinds of like weird shit like that in JavaScript. And so I've been trying to teach you all of the ways that like just make that not a problem. And so that's why we only use triple equals, for example. But yeah, there are some kind of weird ones like that, like this. I have no idea what that's doing.
I tried it out a little bit and like flipped to less than and some other characters, and that, it looks like it's doing the length.
Okay, there you go. Can I say true is greater than false? Weird. Weird.
Are there default values for Boolean?
So like I would call false the equivalent of an empty value for Boolean.
Okay.
So is false greater than true?
Apparently.
It's impossible.
Yeah, guess so. And it's probably because it's coercing it to a number, because when you coerce a Boolean to a number, true becomes 1 and false becomes 0.
Ah, makes sense.
Yeah.
Because 0 is falsy.
Because 0 is falsy! Ah, look at you! Love
Good job,
it!
Sean.
Boolean operators. And like these Boolean operators, these will definitely coerce something into a Boolean. So if you do like that and that, the actually the thing you get back is called a short circuit, but that evaluates to true, or evaluates to whatever its Boolean value would be. So that and that is false. An empty string is falsy. And so if you were using that like in an if statement or something, like that if block would never run because it gets treated as false. So those are operators. Expression, something that evaluates to a value. All of these are examples of expressions. Here's some good rules. Anything that uses an operator is an expression. Any function that returns a value is an expression.
I like that you got Bryce in some of those examples.
Yeah, we did this for warm-up one morning. Statements and instruction. Oh yeah, some more rules that you can go off of. Every return in a function is always a statement. Any variable assignment. Function calls. Those are all statements. Control structures. If, switch, for, while, try catch, those are not values, they're not statements, they're not expressions, they're control structures. They just control the flow of like logic in the program. And then these are some examples of declarations. Ta-da! And that, like, all of this stuff is core programming kind of things. Like every programming language has these same ideas. So you're going to get a lot of mileage out of those. Questions about any of our programming concepts?
So sometimes I have a hard time like taking this because it's very simple and then like taking it into a more complex. But if we, so like you talk about learning, we're just following rules right now.
Yeah.
So if we just stick to this, like focus on like as I'm going into doing like fetches and that kind of stuff, that's like the rules, right?
Yep.
Okay.
So like here's how this applies to some of the stuff that we do. Like if I think I have a Pokemon in here, Pokemon shower. Star Wars video library. So let's look through some of this. All of that, statement. We're assigning something. Specifically, we're assigning this value, this array of objects, into the film's variable. All of this, statement. We are invoking the for each function, passing that function into it. Statement. Expression. New hop element dot query selector. Not new hop. Come on, Coverly. New hop element dot query selector passing in title. All of that evaluates to a DOM element, which is a value. That evaluates to a DOM element. This evaluates to a string. So film.text content is now a string because we did that assignment. That whole assignment thing is a statement. All of this is a statement. It's also an expression because it evaluates to a promise. .then is a method that's available on all promises. The fetch expression evaluates to a promise, so we can call .then on it. This whole thing is a statement because we're doing an assignment. All of this stuff from the map is an expression that's going to evaluate to an array. This map always evaluates to an array. Response is an object that has a results property that evaluates to an array. Arrays have map methods on them because of the prototype. So we can map over that, and when we do, that's going, the whole thing is going to evaluate to an array of objects that look like this. And that because we're assigning it into a variable, that makes the whole thing a statement. This is a declaration. That's a statement. This is an expression that evaluates to an empty DOM node. This is a statement because it's calling the add method of these things. We can also infer that this is an object because we're dotting things off of it. So movie listing dot class list also evaluates to an object because we've got something that we're dotting after that. And then that object has an add method that takes in a string. This is a value, which makes it also an expression. Whole thing is a statement. That is an expression that's going to evaluate to, I'm guessing, a string. So I could use this get poster call. I can use that everywhere that I can use that and the string interchangeably. So like if the poster URL was good url.png, that value, this expression, and this variable are all the exact same thing. I can use them all interchangeably. I could do good URL dot length. I could do that same thing off of that. I could do the same thing to that, and I'll get the same thing every time because they're identical values. Sometimes it's the actual value. Sometimes it's this expression that evaluates to that value. Sometimes it's this variable which is storing the value. All of them are the same though. Questions about any of that? Let's see, what else was in this reading code thing? I don't think anybody's actually having trouble with math. Let's talk about variables. Yeah, let's talk about variables and then maybe break for lunch. So, assignment statements. This is related to what we were just talking about. Variable's a container. It stores values. If you assign an expression into the variable, whatever that expression evaluates to, its value ends up going in the container. It doesn't remember the expression that made that value. It just evaluates the expression, takes the value, tucks it in there. If we're going to allow a variable to change over time, let. Otherwise, it's const. Always, always, always. Const is a better default than let. It's a little counterintuitive. It's like, hey, why would I take away my freedom to reassign a variable intentionally? It's because most variables you probably don't want to reassign. And if you accidentally reassign them, const will catch that and go, nice try, asshole, and not let you do the reassignment. If you are like, no, JavaScript, I know what I'm doing. I actually did want to do that reassignment. All right, well, then just change your const to let then. Otherwise, if I see let for a variable name, the first thing that I'm doing is scanning through the rest of the code to see where it changes. This is like a hint to the developer that name changes over time. Most variables shouldn't do that. So const is our default. Hey, this looks familiar. There was one other thing that I wanted to talk about with these. Oh yeah, names. So we've talked about this a bunch, but coming up with good variable names is very difficult. So here's some guidelines. We don't do programmer abbreves. It doesn't like make the code run faster. If instead of writing index, I write IDX, who's that for? Like, the computer doesn't care what I call the variable, so it's not for the computer. Like, I've made something that's difficult to pronounce. You could say IDX, or you could just say index like an actual adult. And really what you're doing is you're putting the cognitive load on the person reading it to read IDX and then use their brain to retranslate that back into index in your head. So the computer does not care whether or not it's index or IDX. Your brain does. So you chose the one that makes your brain work harder? No, that's silly. So use the entire word. Your brain will thank you one of these days. When you're like just rocking back and forth, go, why am I making my brain retranslate this shit all the time? Same with single letter variable names, anything like that. It feels more like programmery, which is like the dumbest reason to name your variables that way. All right, cool. Ask me some questions about variables.
You personally have an issue with var everywhere else I go. I consistently keep seeing var used as a variable, and it works closer to let than it does const, right?
You are correct. So var kind of died 7 years ago. Not everybody got the memo. But the difference between them is var is block scoped. So var is function scoped. So if I have an if statement and I make a block and I use var, that works outside of this block, because as long as it's in the same function, or if it's not a function at all and just in the global scope, JavaScript doesn't care about blocks. All it cares about is functions or the global scope. If I do that same thing with let, A is undefined because it's the block is considered a nested scope. This is the way that it works in like every language. This is some weird stuff that Brendan Eich did in 1995 when he was tired. But yeah, there's no good reason to use var in the year of our Lord 2022.
Excellent. I'll start disregarding and thinking less of those people.
You probably should. Like, when you see a resource that's using var, that is something that's at least 7 years out of date, or if it's not, then it's somebody who like has not stayed plugged into what's happening in JavaScript for 7 years, because we all had a big meeting and decided we weren't doing that anymore.
I somehow clicked on like Gmail and got into inspecting it and looking at their JavaScript, and it's all like single lined, and the variables they use are like E, A, D, whatever. You can't read it.
So it wasn't written that way. That's called minified and uglified code. So there's a whole bunch of things in your code that you care about, the computer doesn't. So like, for example, white space makes it a lot easier for us to read. The computer does not care about white space. So this function, let me do a shorter one. This function here, if I put the statement terminators on here, I could just as easily write this like that. That's also legal code. And I took out those new line characters, so it's technically smaller. All right, well, what about the spaces? JavaScript doesn't care about spaces. I think I need one there. Don't need it there, don't need it there. Don't need it there, don't need it there. Don't need it there.
So it all just comes down to readability.
Right. So this is exactly the same as what I started with, just with a lot less spaces. All right. Well, also, the computer doesn't care with these like awesome descriptive names. If I make that A, I didn't change the logic of the function at all. If I make that B, I did not change the logic of the function at all. If I make that C, I did not change the logic of the function at all. I did make it a lot shorter, though, and so on. So this process, the process of like getting rid of all the white space is called minification. The process of rewriting all of the function names and variable names and stuff to like single letter variables, that's called uglification. But all of it is about performance. So like that is substantially fewer characters than that. So that means it takes less time to send over a network.
And do they have someone that does that process, or is that all automated?
All
like
automated.
To take it?
Oh my
Okay.
God, manually uglifying something would be excruciating. No, they're plugins that just do it, and they do it automatically. You push up to GitHub, and then that starts off a whole chain where it like minifies your code and uglifies it, and then does a thing called gzipping, which is like putting it in a zip file basically, and making it as teeny tiny as possible, so that when somebody requests it, it comes over. You're sending as few characters as possible.
But going into the source code, if you're able to do that on something like Brad's Gmail example, that's where it wouldn't have these kinds of automated features in it.
Not the source
And we could
code,
actually
just what you got back from the browser.
Let's see.
So, in fact, I'll bet if I look at my code on here, it's probably minified too. It is. No, not the stack trace. Where is it? There we go. No, this doesn't have my files though. No. All right, so what JavaScript did I get? All right, let's take a look at this JavaScript file. Hey, look, what do you know? I didn't write that. And that has the entire React framework baked into it too. But yeah, that's the smallest that my uglifier could make this code. .29 megabytes. Good Lord, that's a lot of JavaScript. Questions about variables? One other thing I want to caution you about with variable names is that's a pretty good variable name. First name string is a terrible variable name. It's really tempting when you're starting programming to just throw the type into the name of everything. So you have like person object or Pokemon array So the reason I don't like this is because you're setting yourself up to be a liar. If this gets reassigned, or this person object is actually an array of objects or something, or you coerce it to something else, don't put the type in the name. Just say person and Pokemon. Or if it's something that's uncountable, like Pokemon, I don't mind Pokemon list, Pokemon collection, but we're trying to not use technical terms. We want to describe it in terms of what it is. So in a way that like a non-technical person would kind of understand. You'll end up with much more what we call expressive code. Expressive code is where you can look at the code and get an idea of what the person was intending to do. That's a lot easier if you're not including the types in the names.
And I also learned that when you're using const, if you try to use it again, VS Code will say, hey, you can't use that one.
Can't reassign it. If you've done something with const, it cannot be reassigned. All right, any last questions about variables before we break for lunch? All right, so we've been through programming, input and output, expression statements, declarations, that kind of stuff, variables. So when we get back, I want to start doing conditional stuff, function stuff, scope stuff, iteration stuff. Sound good? Sounds good. All right, let's get back in an hour. So 12:50. See you then.